Hello, hello, welcome. We're so happy to be here today with Semgrep, a WiCyS strategic partner for a WiCyS webinar. My name is Lynn Dome, and I'm Women in Cybersecurity Executive Director. We often go by our acronym WiCyS, and we spell that WiCYS. And we pronounce it WiCyS, like we sisters, because that's exactly what we are. We're a global cyber sisterhood. So our mission is to recruit, retain, and advance women in cybersecurity. We have over 6,800 members with representation in over 70 countries. On top of that, we have 56 professional affiliates, and professional affiliates are mini WiCyS organizations all throughout Africa, Australia, Canada, France, India, Pakistan, Norway, Tel Aviv, the UK, and throughout the United States. We have 2 corporate affiliates, WiCyS MITRE and WiCyS Lockheed Martin, and we have specialty affiliates in AI, BISO, critical infrastructure, cloud security, data privacy and cybersecurity law, LGBTQ plus pride, neurodiversity, military, colors of inclusion, Latinas and cybersecurity, and so many others. And then in addition to all of that, we also have over 200 WiCyS student chapters with Microsoft Philanthropies funding a global student chapter initiative. So what we do is we provide opportunities. We are a member-based organization where all our members can network and connect. We have many different skill development training programs funded by Google, Meta, Bloomberg, Craig Newmark Philanthropies, Target, SANS Institute, ISC Squared, Fortinet, AWS, and so many more. We offer scholarships, grants, and awards not only to our conference, but to other conferences as well. And our conference is coming up March 16th through the 18th at the Gaylord Rockies in Denver, Colorado. We have our Cyber Talent Emergency Fund for students to receive up to $599 within 48 hours for true financial emergencies like medical bills, or their car breaks down, or they have to pay for rent or a portion of their tuition, because we don't want anything to derail them from their cybersecurity studies. We offer speaking and media opportunities for our members to be what others can see, and that's the cybersecurity professionals they are. Our Job Board Plus Plus is a place for strategic partners like Semgrep to recruit from and to post their jobs and get access to resumes. And it's a place for all our members to post their resumes and get recruited from. We have an apprenticeship program, employer internship program. We participate in market research right now. We're doing an inclusion assessment on the state of women in cybersecurity. We have leadership summits, leadership series, speakers bureau, mentors, mentee, and so many other initiatives. So we owe all that thanks to our strategic partners. As you can see, that Semgrep is a wonderful strategic partner of ours. And we have our tier 1 partners, AWS, Patel, Bloomberg, Carnegie Mellon Software Engineering Institute, Cisco, Fortinet, Google, Intel, Lockheed Martin, Meta, Microsoft, Optum, Sandia, National Labs, and SentinelOne. So we have these lovely ladies from Semgrep here, Colleen and Emma, and they're going to be presenting today. So now is your moment to be able to ask questions all throughout the webinar. They're going to be queuing up, and we're going to be prioritizing them as they come in so that everyone could get those questions answered either through the webinar or at the very end. And if you haven't done so already, I would encourage you to go to WiCyS.org and subscribe to our newsletter so you never miss a beat about enrollment of the Mentor-Mentee program or scholarship opportunities, or to participate in any other skill development training program. So before I pass the mic on over, we want to encourage everyone to participate in the survey. And the survey is going to be in the announcement section at the bottom of your screen. So I'm going to go ahead and stop sharing my slides right here. And just as a note, everyone could enter to receive a $250 Amazon gift card if they complete that survey. And the winner is going to be announced at the end of today's webinar. So you could be the lucky winner. How exciting is that? So without further ado, I'm going to go ahead and have Colleen and Emma take it from here while I go ahead and put that survey link in the announcements, and we'll follow up with you at the end of today's presentation.
Awesome. Thank you so much, Lynn. We're going to get started on our presentation then. So today we'll be talking about how to catch the OWASP Top 10, which you might have heard of, and is essentially a list of the most critical web vulnerabilities early on in the development process. So here's a brief overview of what we'll be talking about today. So we'll first discuss what OWASP is and what the OWASP Top 10 represents. And then we'll talk a little bit about why we should be catching these bugs early on in the development process as compared to later on. And then we'll teach you how to do this a little bit using some automated tooling. And then finally, we'll have some time for a Q&A where you can ask us anything really. Awesome. So who exactly are we? I'm Colleen, and I'm currently a security researcher at Semgrep or R2C. And I've been a security researcher for around 2.5 years. And my job is essentially to look into security vulnerabilities and how to really consistently prevent these vulnerabilities. And this is my first job out of college. So I graduated in 2020 from Stanford with my bachelor's of CS and my master's of statistics. And some of my hobbies include finding people. I'm also on Twitter, so feel free to give me a follow if you're interested. And I'll pass it to Emma to introduce herself.
Yeah. Hi, I'm Emma. I've been a software engineer at Semgrep for 2 years, so a little bit less, where I mostly work on the engine of our tool. Before that, I was at Carnegie Mellon University studying computer science. And in my free time, I like to write and ice skate.
Awesome. Thank you, Emma. So let's talk a little bit about what OWASP is and what the top 10 really is. So let's imagine this. So you're a security consultant sort of right when the security industry really started. And you look at your web applications and you notice that there's around 15 high priority issues. And these are pretty significant issues that could lead to your company's sensitive information being stolen 5 to 6 different ways. You're also one of the only 5 security engineers at a company of 200 plus people. So everyone on your team is pretty stressed out dealing with similar issues in different areas. So you might ask, what do we do from here? How do we know what to prioritize? How do we even know what to fix first? In a lot of cases, how do we even know what to look for first? And are there any resources out there to really help us find what the best way to fix these bugs are and to really prevent them? Are there any resources out there to really help us make our company more secure in the best way possible? Well, a lot of security engineers really had the same problems and also the same questions. And they all bonded together and decided to form what we call OWASP now, which is the Open Web Application Security Project. And OWASP is essentially a nonprofit with the goal to really improve software security. And there's a lot of notable projects that OWASP has really done over the years. So some examples are, for instance, the Application Security Verification Standard, or what we call the ASVS. So what the ASVS does is it's a standard for testing some web application controls, and it lists some secure development requirements. Some other notable projects are, for instance, the OWASP cheat sheet series projects, which really explain some specific vulnerabilities and what patterns lead to these vulnerabilities, along with how to prevent them. And I've personally referenced the OWASP cheat sheet series projects a lot in the past few years, and they've been really helpful to me personally. Some other projects include JuiceShop and WebGoat, which are purposely vulnerable repositories that you can try to hack or try to test your skills on. But what might be most famous is the OWASP Top 10. And what the OWASP Top 10 is it essentially lists the most critical web application vulnerabilities according to the OWASP Foundation. And OWASP releases a new top 10 every few years. So you might ask, how does the top 10 really get decided? Do they sort of draw some slips out of a hat or something like that? Well, not quite. So if we look into how the OWASP makes the OWASP Top 10, we see that it's more or less a 2-step process. So the first step in the process is to essentially collect some data. And this is data contributed by organizations that have really collected web application vulnerabilities throughout the years. And the data is what defines 8 of the risks of the top 10. They also don't purely use the statistical data because it is sort of incomplete and biased a little bit. They publish a call for data through some social media channels and also work with other organizations. So a lot of these organizations that they work with are a certain type of organization that really sometimes cares about security. So the statistical data is incomplete. So to give a good sense of how much data that they collect, in the 2021 call, the first part of it, there was over 228,000 applications that were submitted. And the second part is the survey or the industry survey. And it lets security people rank what they believe are the most important. And security engineers, a lot of them have a lot of good opinions. So it's really good to have an industry survey to sort of let them tell you or let them show what they believe is the most important. And this defines 2 of the top 10. And after that, after all of the top 10 are selected, they apply some generalized factors like exploitability, detectability, and impact to sort of rank the top 10. And we see that there's a poll for when the OWASP top 10 was first released. And essentially everyone is quite right. It was first released in 2003, and there's been updates to the OWASP top 10 every few years. Awesome. So let's talk a little bit about what's actually on the OWASP top 10. So 2021 is the most recent version, actually, and this is a list of what's on the top 10 in 2021. And feel free to click the link to really look at it more, but we'll briefly describe a few categories and then sort of move on. So A1 is broken access control, and it really talks about enforcing access controls so that users can't act outside of their intended permissions. So for example, if a user is acting as someone who's logged in, even though they're not, that's an example of broken access control. And same thing for when a user is really acting as an administrator, even though they're logged in as just a basic user. A2 is cryptographic failures, and it really tells how data is protected in transit and at rest with cryptography. So if data is transmitted in clear text, this is pretty bad because essentially if anyone was listening in, they could really tell your secrets and just gather that information. So that's A2. But today we'll really be focusing on A3, which is injection. And this is a category that's really been around for a lot of years and has a lot of vulnerabilities you've probably heard about. So we'll talk a little bit about injection. So what essentially is injection? Well, it occurs when some untrusted data is executed as part of a command or query. And this can be bad because an attacker can really trick the program to execute some commands, access some sensitive data, and even destroy entire databases. So a quick example is, for instance, if an attacker tells a vulnerable server to execute some commands and destroy the files. And because the server is vulnerable, it destroys the files. Awesome. So let's talk a little bit about what's included in injection. Injection is a pretty vast category. So there's a lot of smaller vulnerability classes that are really included in the injection OWASP top 10. So some examples you might have heard of, like cross-site scripting, command injection, SQL injection, LDAP injection, etc. But what we'll be focusing in on today is indeed SQL injection. So here's a brief example. Let's say our server has some codes like this. So this is Java codes, and essentially we can see that what it's doing is it's getting some user inputs with request.get parameter and storing it in strings user and pass. So essentially we're also building a query from these strings user and pass. And the query we're building is we're selecting an ID from this users table where the username is equal to this user input that we pass in as user, and the password is equal to this user inputs that we pass in as pass. And then ultimately we're executing this string query and getting some result from the database. So why is this bad? Does anyone have an opinion? You can feel free to post it in the questions portion. Yeah, so no questions yet, but let's move on and sort of see what the potential malicious input is and why this is bad. So essentially, if we take a look at this query again, we see that we're directly concatenating this user input to this string query. And this is pretty bad because it lets the user do more than you would like them to be able to do. So let's give an example. So this potential malicious input is the string password set to passwords quotation mark or 1 = 1. And this is bad because essentially the query that comes out of this is this. So it's select ID from the users table where the username is equal to whatever username you put in and password is equal to password or 1 = 1. And 1 = 1 always evaluates to true. And essentially, this will return an ID from users, whether the user password is correct or not. So essentially, because 1 = 1 is true, this entire where statement also evaluates the true, and the user's ID is returned, regardless of whether you know their password. So this leads to an attacker gaining some privileges that they really shouldn't have, and can also lead to people stealing credentials, gaining access to things that they shouldn't be gaining access to in the first place, accessing databases, and even altering your data with some similar methods. So this is bad, of course, and this is also an example of injection. But why essentially are we focusing so much on injection? Well, this is essentially because it is always there, and it's always really been in the OWASP top 10. So if we look into the OWASP top 10 2013, A1 is injection. In 2017, A1 is also injection. And in 2021, it's dropped in a little bit in rank, but A3 is injection. So there's a few theories as to why it's actually dropped in the OWASP top 10, and my opinion is that this is from a lot of effort in the security community to make frameworks and languages a lot easier for developers to write code without these injection-style vulnerabilities as compared to writing code with these injection-style vulnerabilities. So this is actually a shift that's been happening over the past years, and it's because the shift is that security things that you really had to opt into and try to figure out and configure yourself have become on by default. And this makes it a lot easier for developers to really code securely as compared to code insecurely. So for instance, as an example, some frameworks like React now automatically escape variables and views, and this really prevents cross-site scripting. This is also on by default, so it just makes it a lot harder for developers to really have cross-site scripting in their codes. Of course, it always can happen, but it does make it a little bit harder. But also, you might say, oh, but injection is still really highly ranked in the OWASP top 10. And this is true, and also partially due in part to some legacy codes, functions that are labeled poorly, like Ruby on Rails HTML safe, that actually requires input that is already sanitized instead of making your input safe. So just things like that can be really confusing. But it's not just injection that you can tell really remains on the OWASP top 10. So what else in the OWASP top 10 hasn't really changed? Well, a lot of it, actually. So if we look at the OWASP top 10 in 2013 and compare it to the OWASP top 10 in 2021, we see that essentially a lot of it has stayed the same or just been configured into sort of different categories. So essentially, this is partially because OWASP has actually started to avoid jargon like XSS, like CSRF, because these acronyms are great gatekeepers, but it's also because the OWASP top 10 still really hasn't changed in these 8 years. So because we haven't really succeeded in eliminating a lot of these OWASP top 10 vulnerability classes, we need to take a really good look at what the security industry has been doing and what we want to be doing moving forward. So you might ask, why are these vulnerabilities still so common? It's a great question. So let's take a look at what the security industry has been doing. And what we see the security industry doing is what we call bug whack-a-mole. So this is essentially finding individual bugs and squashing them. And we can do this using pen tests, bug bounties, things that you might have heard of or been part of. But what the security industry is really trying to move towards is what we call secure guardrails, which is essentially making it easier for developers to write secure code as compared to insecure code. And this is hard, but it involves eliminating entire bug classes instead of just eliminating individual bugs. It also helps, it also involves enforcing safe patterns and continuous code scanning to make sure that developers are always aware of what's secure and not secure. Secure guardrails is something that we've been working towards for a few years, but it is really hard and a lot harder than you would think. So a lot of this has to do with maybe company politics because the financial and security benefits are hard to quantify, but also because we need a lot of developer adoption and trust. And essentially, this can also lead to more sort of alerts on the security side, and these alerts can be really hard to filter through because if there's too much, it's essentially the same as not having any alerts at all because you're too overwhelmed to just really search through these alerts. So now that we sort of have figured out this problem that the OWASP top 10 has really stayed the same, let's talk a little bit about what we should move towards in order to eliminate these vulnerability classes. So let's talk a little bit about why we should really catch bugs early on. So let's imagine this first scenario. Let's put ourselves in the shoes of developers. So we're coding and we really push out some code to a centralized repository. And after, for instance, a centralized repository like GitHub, and after we push out our codes, we see that this application has flags of vulnerability in our codes. So of course, we're first like, what is this? Let's see if this is an actual vulnerability. And once we look into it, if we realize that it is actually a vulnerability, we cry a little bit inside. We think about how to fix this vulnerability, and then we push out a commit to actually fix this vulnerability. And after we push this commit, we're mostly done because essentially this code isn't released to the public and we don't need to do much more. So this did take some time to think about the fix our codes, commit it again, but it wasn't altogether that bad. Okay, now let's imagine this second scenario. Let's picture this. Essentially, this white hat hacker submits a bug bounty report to our company, and it's a vulnerability in our feature that we built. So we ultimately get the report, and essentially because we know the codes best, we are tasked with fixing this vulnerability. But the feature we've released has already been public-facing for a while, so a lot of customers are actually using it. So what do we need to do in order to fix or patch this vulnerability? Well, a lot more than you would think. So the first step that we have to do is, of course, plan to fix this vulnerability, much like we did in the first scenario. We also have to code to fix this vulnerability, a lot like we did in the first scenario again. And then we have to test this fix and make sure that it doesn't break anything else for customers. Once we've tested this pretty thoroughly, we can ship it to customers so that they aren't using old vulnerable codes and that they can make sure that their stuff is safe too. So after we ship this, we do really need to monitor in order to make sure the after effects of the patch don't cause any problems. And in fact, we might have to do this all over again if there are problems. And doing this all over again is actually quite common. So it's definitely a possibility that we want to consider. So in fact, what we've done is we've gone through most of the steps of what we would call the DevOps infinity loop. So what exactly is this infinity loop thing? Well, it's a model of a software release cycle that allows teams to really build and deploy software continuously. And this allows us to make some timely security and feature updates. So the DevOps infinity loop sort of indicates how developers and operations teams can really work together so that customers can get the best updates as soon as possible. So let's delve into a little bit of the DevOps infinity loop and what the steps are. So previously in our second scenario, we thought a little bit about it in the sense of releasing a patch. But let's first think about it in the sense of releasing a feature or a set of features. So the first step is to really plan out your list of features that you want to release, and then you want to code these features up. So after you code these features up, you actually compile this code into a binary that is easily shippable and easily used by your customers. And then you really want to test this well and thoroughly so there's no problems. And after you test, you release this to your customers, and you do this automatically and continuously so that they can get updates. After we release this to our customers, we want to really oversee the software in production and continuously keep our eye on it in order to make sure that there's no problems. And if there is a problem, we can go through this entire cycle again. Cool. So you might ask, what does this have to do with me? I'm not a developer. Well, essentially, how does security fit in to this DevOps infinity loop? Well, it fits in everywhere. So we have security in all aspects of the DevOps infinity loop. It's definitely possible to fit in everywhere. And it really is good to fit in everywhere because we do want security in all aspects of the DevOps cycle. So this really just serves as an overview of what can be done for security at each stage in the DevOps cycle. We won't go into super detailed talking about every step, but essentially some examples are for the planning stage, you can do some threat modeling. For the coding stage, you can do stack analysis, pre-commit code review. Deploy stage, we can do bug bounty, pen tests, etc. And what did we focus more on previously? As we were talking about secure guardrails versus sort of bug bashing, we focused more on bug bashing previously, which is why a lot of the OWASP top 10 has stayed the way it is. And bug bashing is really done in the deploy stage after we've really released all of this and we get some bug bounty or pen testers to see what's wrong with our application. So we were focused more on the later stages of the DevOps cycle previously. But what do we want to focus on more? So if we look back at the scenarios we had as a developer, the first scenario took us a way shorter time to fix than the second developer. And this is generally true. The later we push or the later we discover a vulnerability, the more time and developer time it really takes us to fix. And of course, time is money, and money is what corporations really look at. So how much does it cost to fix a vulnerability? So this is my very extremely hand-wavy graph. And on the x-axis, we see that this is the stage we caught the vulnerability. And on the y-axis, it's a very hand-wavy unit for money. So if we catch the vulnerability in the planning stage, there's not a lot of code that has been written, so we can just plan it differently. And essentially, this takes very little money and time. If we catch it in the code stage, we see that we, much like in the first scenario, we have to figure out the fix and then push the fix. And it does cost some developer time, but it's not altogether that bad. If we find it in the test stage, which is also pretty likely, it does take some time to test it and then correct it. And there might be separate testing and coding teams. So it might take even more time because there's communication between teams. And once the corrections have been done, you have to talk to the testing team to test it again. But it's altogether not too bad because we haven't really released anything to the public yet. But if we catch the vulnerability at the deploy stage, we see that it takes a lot of effort to push out a patch, much like what we did in the second scenario. And we might have to do this over again if there's something wrong with our patch. And it can also ultimately result in a loss of customer trust because they've realized that you aren't keeping your code super safe and they might switch to another competitor. So this is pretty expensive. So some other reasons as to why it's worth investing in catching these bugs early is that making it easier for developers to program securely actually leads to less bugs overall. If we look back into sort of our bug bashing stage, we were just squashing individual bugs, but by catching it early and making it sort of harder for developers to write insecure code, it actually can lead to vulnerabilities or vulnerability classes being eliminated instead of individual bugs. So building security into these frameworks has a bigger impact than just reacting to individual bugs. And another thing to really consider is the relationships between teams. So security is never a standalone team. Our relationship with our developer teams is really important. And if something takes a little bit longer to fix or something goes wrong and is not part of the developer roadmap, they tend to see security as more of friction and something that's causing them to work overtime, not a business enabler, which is what we want people to see us as. Another good thing to notice is that developer time is money, and the more time it takes to fix, the worse mood people will be in, and therefore it's more likely that people will view security as friction. And overall, it does make it easier for the security team to catch things early, because then we can sort of eliminate vulnerability classes instead of individual bugs. And we can use some tooling like static analysis to prevent some specific code patterns and just prevent these entire classes of vulnerabilities from happening. But don't just take our word for it. Let's see what other teams are also doing. So in AppSec Cali of 2018, Netflix has stated that essentially what they're de-emphasizing is manual testing and traditional vulnerability scanning, and what they're trying to emphasize instead is killing bug classes as a whole. And it's not just them. Facebook has also stated that they're trying to invest heavily in building frameworks to help engineers prevent and then remove entire classes of bugs when writing codes. And if you look at their defense in depth approach, we see that what they're focusing on and what is the foundation of their defense in depth approach is secure frameworks. So it's not just Facebook and Netflix, it's also Google. So Google in their book, Building Secure and Reliable Systems, has actually stated that it's pretty unreasonable to expect a developer to be good at writing codes and also an expert in security and reliability. So a better approach to do this is to actually handle security and reliability in these common frameworks languages and libraries that developers use. And ideally, this makes it such that writing code with common classes of security vulnerabilities is impossible. So overall, what do we want to focus on more now that we've sort of seen examples of what other teams are doing? Well, we want to focus more on the beginning part of the development cycle. So this includes the planning and code portions. It's not to say that we don't want to do any of the rest, but we do want to shift our focus a little bit to earlier in the development cycle. And what we're going to be talking about today, we'll be focusing on today in particular, is static analysis. Not because the other things are less worthy, but because that's sort of our area of expertise. Threat modeling, all these things are really interesting, but we're going to be talking about static analysis today because that is what we work on. So cool. Any questions currently?
Yeah, there's one question. So give me a sec. The question is, from your experiences, have you encountered certain types of databases being more vulnerable to attacks than others? Not looking for anything specific, but interested to know if this should be considered when selecting a new technical stack and at the project implementation stage.
Yeah, that's a great question. I think essentially that's what you want to look at more specifically is how you interact with these databases. So for instance, there's ORMs, which are good for interacting with these databases, and sort of just like these frameworks that allow you to automatically like parameterize your queries and make it a lot harder for you to actually do SQL injections. That's what you want to look for. So essentially when you're looking for a framework to really interact with your database, make sure that it's something like an ORM, or just makes it easier for you to not write insecure codes. Or essentially maybe it's not even you, it's your developers. So focusing on that, I think is really worthy.
Great. That's the only question right now. So we'll move on, but please keep leaving your questions and there will be more question answering time at the end.
Awesome, cool. And I'll pass it to you now, Emma.
Yeah. Thanks, Colleen. So now that we've talked about what the OWASP top 10 is and why we should catch those vulnerabilities early on, let's talk about how to do this. So like Colleen said, for today, we're going to be focusing on SAS, static analysis, because that's what we do. But also, it's what we do it because we think it's really important. With static analysis, that you're able to have a tool automatically scan and understand your source code, and therefore tell you where your vulnerabilities are without you having to read it. Which, given what Colleen was talking about with how these vulnerabilities have stayed the same, how these are known, that's super useful because you can have a tool just check for these known vulnerabilities, and you can focus on what's interesting to your code. So when you're choosing a static analysis tool, what you need depends on what your use case is, right? Like if you're working on critical infrastructure, you probably need more like formal verification. If you're just looking for some dangerous function, you could be fine with just grep. But for most use cases, you want something that's lightweight, fast, and customizable. This last is really important because every code base is different. And the more you can tailor your checks to your code base, the more you'll be able to enforce the best practices your company specifically uses and therefore make the results precise. So Semgrep is the tool that we work on. It's all of those things I mentioned. And in addition, it's free and open source. So for the rest of this presentation in these demos, we'll be using Semgrep as an example. So this first example, let's look at some JavaScript code. In JavaScript, there's this function called eval, which can be dangerous. What eval lets you do is execute arbitrary code. So if you did eval x plus 1, where x was 1, that would give you 2. So that's fine. Yeah, you can also do like eval var x equals static strings are okay, and that'll assign static strings are okay to x, which is also fine. But down here, this code is a little more dangerous. We have let dynamic equals window.prompt. And here we're just taking whatever that prompt window ingested so that the user can input into that, and we're just evaling that. So this is dangerous because the user could put in something like ls or rm-rf, like they could delete all the files. They could say read all of your sensitive information, and we don't want that. So let's write a check for this. I'm going to switch over to our playground. Let's see. Hopefully I get the right one when I click. It looks right. Yeah. So this is real quick, our playground. You can write rules and explore how they work on code. And then using this, you can add it to whatever flow you're using. So let's write a rule for the example we looked at. What we want to find is any use of eval. So we'll just say eval ... And this will find all the uses of eval. But actually, let's refine this a little bit more. We want to include eval, but we don't want to include cases where we're evaluating a static string, because like we said, that's fine. That's safe. We're defining what we're evaluating. So here, this rule, we can just really quickly refine it and make it so that it matches the cases we care about and cases we don't. Okay. So let's go back. I'm going to have this open the slides again. Let's look at, so now that we've gotten a brief overview of Semgrep, let's look at something a little more complicated. We're going to go back to the SQL injection vulnerability we saw before. So as a quick refresher, here the problem is that, as one of the people in the audience pointed out, because we're just concatenating the user input, user and pass to the SQL query, there's nothing requiring that the password be their password. It could be some command to get all of your secrets. So, and then we're just going to execute that query. So let's write a rule for this. I'm going to spend a little more time going through this rule because it's a little more complicated. So first, what we're going to do, here we go. First, what we're going to do is we're going to specify what the source is. The source being the potentially dangerous input that, it could be a password or it could be a command to steal all your secrets. And so in this case, a source looks like something.getParameter, because we know that that means we're getting something from user input. And then we're going to specify what the sink is. In this case, the sink is execute query. This is just the dangerous function, the function where if user input can get in there, that would be bad. So now let's come back over here and look at running this rule. Once again, let me hopefully get the right tab. No, that is not the right tab. Okay, so here we have just the rule that I showed before with some other information. And if we run this, in fact, we, oh no. Sorry, if we run this, in fact, we are going to find a result. We're going to see that user and pass, which are both user input, they're going into the query, and it's going finally into the execute query. But as we saw earlier, because I accidentally had this in the wrong state, if we don't, if this is just a static string, or if this was some other constant and it didn't have user input coming in, we wouldn't have any result. And we can also see, if we changed user and pass to like user and pass. So this too would not match, because it's checking specifically that your user input is flowing into the dangerous function. Yeah, so now that we've seen those two examples, what does this actually look in the real world? We use Semgrep, people use Semgrep. How does this work? So here's a real life case of a rule that we wrote. A while back, we investigated how GitHub Actions can be compromised, and we wrote a blog post about it. This is a really cool blog post and really fun to read, so I highly recommend it. But for this talk, we'll just focus on one of the injection vulnerabilities that we talked about in that blog post. Quick recap, GitHub Actions are used to automate development pipelines. So this example GitHub Actions just shows like some jobs. The important part here is the run command, because whatever's run, that's kind of like eval. It's just going to run whatever you have there. And so if you run something, so in this run, what we're running includes the title, which is being set to the pull request title. But if you have an open source repository like Semgrep, anybody can make a pull request to your repository, and they can make their title whatever they want. It doesn't have to be just a normal pull request title. So then that title can get injected into whatever else we're running, and we might run something malicious. So we wrote a rule to prevent this. It just checks for something to run. We can take a look at that rule really quickly. So this is the rule. What we're looking for basically is that there is, within these steps, there's this run that uses the pull request title. And as you can see, this rule matches the input. The real rule is a little longer because there are many possible sources of input, but that's basically the idea. We run this rule, and then we can catch cases where our code uses these, possibly uses these user controllable inputs. And we've been running that on our code, preventing these bugs from happening. I chose this rule though because it did a cool thing. Let's pull back these slides. As you saw, there are a bunch of inputs, and this rule, like most of our rules, is open source. So an outside contributor actually noticed that there was another possible unsafe input, and they added it to our rule. These rules will automatically run on all of our repos. So once the rule was updated, we found a vulnerability actually because of that new vulnerability that the contributor noticed. And we were able to remediate that and then keep the rule running to prevent more. Yeah, so that's what's really cool about SAST. You're always going to have vulnerabilities. Developers will always make mistakes, and code review can't catch everything. But with a SAST tool that can scan your code, you can teach a tool about these vulnerabilities, and that tool will keep you safe by detecting when these vulnerabilities happen and preventing them from ever making them into your code base. And so once you know about a potential vulnerability, you will never have to make that mistake again. In addition to Semgrep, we have some other projects as well. You should definitely check out Semgrep, but we also create some security cheat sheets courtesy of our security research team. And also we make the Semgrep app, which for people who are building, if you're one of those 5 security engineers working, trying to secure the code for a team of hundreds of developers, Semgrep app will help you ingest the vulnerabilities that you get and prioritize, manage, communicate, keep track of them. So definitely check that out too, especially if you help run a security program. So quick recap. The OWASP top 10 vulnerabilities are a list of vulnerabilities curated by the OWASP project, which for the most part have just been around for years. We want to eliminate these vulnerabilities early on in the development process, because the cheapest vulnerability is one you never write at all. And one of the best ways to do this is with static analysis, so that once you know about the vulnerability, you never have to worry about making it again. To get started with static analysis, if you want to get started with Semgrep especially, we have a bunch of resources. So to learn about using Semgrep, we went over some of the, use some of the basic features, but we have a full tutorial at semgrep.dev/learn where you can learn about all of those features we saw and more. If you want to start running Semgrep, then you can just install it whenever using pip or brew, and then you can try running it using our JavaScript rules on Juice Shop in the command we have below. And also we have a quick start tutorial that's shown with that YouTube window. So if you get the slides, you can always go watch it. And of course, we're here to answer any questions you have. Speaking of which, any questions?
Cool, Emma, I think we got two, so we can sort of also both answer the questions. But one of them is, how does Semgrep reduce or manage false positives in code reviews?
Yeah, so Semgrep will, the main way that we help manage false positives is by focusing on making our tool really customizable. So like you saw there, we had that false positive with eval of a static string. And so you can then add a pattern that says, oh, like a static string is fine, so that shouldn't be a result. You can add also, we didn't go into this, but if you're writing what we call the taint rule, so if there's something, a user input flowing to a sink that you're trying to prevent, then you can add sanitizers curated to your code base that, so like if it flows through that, it's fine.
Yeah, and also I think essentially there is sort of a difference between secure guardrails, which is a good principle to have, and managing false positives. So it is really hard to essentially come up with secure guardrails rules that really don't show up too much. So what we've been sort of focusing on right now is writing taint rules, as Emma was saying, that's really specifically trace your inputs from source to sink, and focusing on making sure that those rules in particular only flag when we're pretty sure you have a vulnerability. So there's always this trade-off of if you focus too much on eliminating false positives, there are cases where you won't actually catch things. And it's a trade-off that I think a lot of security engineers will actually vote for, because false positives are just, well, if there's too many false positives, it's essentially like you don't have anything because you're just not willing to go through these alerts. So there is a trade-off over there, and right now in the security research team, we're really focusing on eliminating false positives, even at the cost of occasionally not finding anything.
Real quick, I see a lot of great questions come in. So before we get to all of them, it looks like we have a raffle winner. Lynn, did you want to announce it, or should we?
Hello. Yes, so we're super excited to announce that Lindy is the raffle winner. So yes, so the Semgrep team is going to be emailing you. So this is very exciting. We're also going to put likely an announcement in the announcement sections, but just be on the lookout for that email and you'll be receiving that $250 Amazon gift card. So congratulations. All right, ladies, then you could go ahead, and we have some questions coming in. So this is excellent. So I'll go ahead and mute myself, and so you could continue answering those questions.
Awesome. Thank you, Lynn.
Cool. Yeah. I think the next question is good for you. There are many vulnerabilities and even more frameworks. So how do you decide what rules to add to the registry? What are the languages you create rules for?
Yeah, so this also has to do a lot with prioritization and how we personally think about it. So some of the things we think about when we're choosing a framework or a specific vulnerability class to write rules for is, for instance, how many of our customers are really using a language or framework, and also if we ourselves are using that framework or are susceptible to a vulnerability class, because we do want to dog food and try our own tool first before we release it to a lot of customers. So that's something that we do think about. Another thing is we do use the OWASP top 10 to really rate which vulnerability classes we do want to focus on. And essentially we think about specifically for Semgrep what types of tools and what types of what the program analysis team can do, such that we can write rules for the vulnerabilities without false positives. Because sometimes we need additional program analysis things in order to write rules that for specific vulnerabilities like cross-site scripting can eliminate false positives for them. So we think about like what type of tooling and what type of tools that we have in order to currently find these vulnerability classes with the least false positives as possible. Emma, do you have anything to add to that?
Yeah, that's pretty good. I think with the program analysis team, we also think a lot about what kinds of use cases we want to support, and we really want to prioritize whatever it is that will help enable developers to keep doing their work. So the next question, thank you for showing the DevOps infinity loop. Never heard of it before. How do you think this would benefit cybersecurity roles to utilize regularly? As security needs are growing in requirement, do you think developers will need to have more security knowledge than now? Vice versa, do you think security experts are going to be required to have more coding knowledge?
Yeah, that's a good question. And I will say I cannot predict the future, but for example, so security has actually changed a lot through the years, partially due to, in my opinion, developer changing developments and sort of the development cycle changing itself. For instance, while we were moving from waterfall to agile, security had to really change with development cycles in order to make sure that we could protect the new cycle as compared to just protecting what we were doing before. So as times change, we also need to change with them. And if you've heard of the DevSecOps before, it's essentially sort of what I was showing with security included in the DevOps infinity loop, which is combining the development, security, and operations teams to really work together and make sure that code is in security is in every portion of the development lifecycle, and we can sort of release continuously and automatically. So I do believe that part of our jobs as security engineers is really developer education, helping developers really code securely, because that is an essential way as to how we can improve security, because we're ultimately not the ones writing the codes, and the code is the thing that can be insecure. So working together with developers and educating developers as best as we can is, in my opinion, sort of part of the job.
Yeah, I think the best way to really distribute your expertise as a security engineer is to let developers own their own security, and which requires having tools that developers know how to use. So I think you inevitably need to like move closer together so that you guys both can use the same tools. And also with like a lot of development frameworks like secure defaults, if developers are able to create their own ways that are secure, and they have their ways of doing things, their good paradigms, then they're the ones who are going to understand those the best.
Yeah, and about do you think developers will need to have more security knowledge than now? I think that is sort of the world that we're tending towards, where not necessarily developers need to have security knowledge, but towards the worlds where essentially it would be good. And also the world that security engineers, at least my view of it, is trying to create, is making it such that the frameworks and the things that developers use make it just easier for them to program securely. So it's not necessarily that developers need to have this knowledge, but essentially we're giving them tools such that they're able to program securely a lot easier than they were before. And I think that's also sort of part of our job. And for security experts are going to require to have more coding knowledge. I think that just really depends on what job you're looking for. For example, for a lot of research jobs, there is a portion of coding. But I think a lot of security engineering and just protect and AppSec and things like that, internal security, you don't necessarily need to have coding knowledge. You just need to understand these patterns that lead to vulnerabilities. But yeah, ultimately, we're all sort of intertwined, so we can't really have one without having the other.
So next question. With Semgrep not performing interprocedural analysis, can we exclude rules from rule sets on the CLI? For example, there may be a legitimate case for an eval to be used. Yes, absolutely. You can exclude, you can customize, like, however, if you're using the app, you can customize however you want, what rules you want to run. You can change the individual rules too, so you can add like special casing. Also, if you just have like one legitimate case for an eval to be used, you can ignore, you can tell Semgrep that, this one case is okay, don't keep flagging it, and I'll do that for you. Great question.
Yep, and also we are releasing something that does perform interprocedural and interfile analysis. You want to talk about it?
Oh yeah. So we're currently working on an interfile analysis engine for Java and JavaScript. So that's coming soon. So stay tuned if you're interested in Semgrep interprocedural analysis.
Yeah. And so
we're also working on something that would perform just interprocedural analysis within one file. So can't give promises on the status of that, but that's in the works.
Yep. And the last question is, does your security team give input directly in your playground? Are they adding new CVEs, or are you responsible for this too? So the security team does give input directly in the playgrounds. If you're asking about essentially whether we use the playground a lot in order to write our rules, the answer is yes. Depends on the security researcher, because I personally don't really use it, but I know people on my team who favor it instead of, for instance, what I use, which is Vim and VS Code. And for adding new CVEs, yes. So we do some research and try to sort of find vulnerabilities in codes using some of our rules. And we do some mass scanning of open source repositories and look for those vulnerabilities occasionally. And we do write a lot of rules for new CVEs that come out. For instance, Log4j, we wrote a rule for that almost immediately after it was spotted as a vulnerability. I hope that answered the question. Yeah. Feel free to clarify or ask more if you are curious.
Cool. It looks like that's all the questions, and also just about time.
Yes, that's a wrap. Well, thank you so much, ladies. We really appreciate you presenting here today, and you had a lot of great questions, and for you to take the time and go through those questions and answer them live, we really appreciate it. Congratulations to Lindy for winning the $250 Amazon gift card, and that gift card is brought to you by Semgrep. So we appreciate Semgrep's contributions, not only to being a strategic partner of WiCyS, bringing this webinar here for the WiCyS community, but also having that raffle as well. And so that's a wrap. We're at the top of the hour. It's a fabulous hour, and thank you for sharing your afternoon with us. Have a great day.
Thank you.
Bye.